In this last part of lesson 3-4, we're going to look at some specific ways that multiplying polynomials come up where people often get things wrong when dealing with them. And the first thing that we're going to do, well, basically what this part focuses on is when you do a polynomial to an exponent. Now, this one is going to just be squared. We're going to square our exponents is just going to be 2. But this is also the way you have to do this when your exponent is greater than 2 as well. So what does x plus 2 quantity squared really mean? Well, it means that you're going to take x plus 2 and multiply it times itself. Now, we just saw in the last part of this lesson that when you do this, you're going to distribute the x into both terms, distribute the 2 into both terms, and you're going to get these 4 terms. When you combine like terms, you end up with x squared plus 4x plus 4. So multiplying or taking a binomial, for instance, and squaring it, the best way to do that is to write x plus 2 times the quantity x plus 2. Now, why people get this mistaken is because a lot of people want to try to just distribute the squared term into both. And this causes a lot of people to write their answer as x squared plus 4. They just square the x squared and square the 2, or excuse me, square the x to get x squared, square the 2 to get 4, and then they get it wrong. And this is, again, totally wrong. So make sure that when you do this, you actually take the x plus 2 times the x plus 2 and multiply it out by each term distributing, excuse me, each term in the left-hand polynomial distributing to each term in the right-hand polynomial. So again, we don't want to distribute this square. Now, that may seem weird because way back in 3-2, we did distribute the square into a term like this. But notice those terms that we were dealing with in 3-2 were monomials. In other words, they didn't have any pluses or minuses. So what this really meant was 7y multiplied times another 7y. And in this case, because all of the operations are multiplication here, I can take, 7 times y times 7, whoops, times y. And because all of these operations are multiplication, I can use the commutativity and the the associativity and commutativity to swap the order of all these multiplications. So I can take this 7 and put it up here. We can't do that. Whoops. So obviously 7 times 7, 49, y times y is y squared. We cannot do that over here because we have two different types of operations going on. We have multiplication between the two polynomials, but we also have addition. So because we have two different types of operations going on, and those operations are obviously on different levels when we're talking about different orders of operations, you can't interchange them. So we have to use that distributive, take this each term in the left-hand polynomial, distribute to each term in the right. Now you can do this with basically any polynomials you want. You can see in example 2 how this is done. 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. Minus 3 times 2x is minus 6x again. And then minus 3 times minus 3 is a plus 9. Combine like terms, you get 4x squared minus 12x plus 9. All right. So notice we end up again with middle terms. Now this is what I was talking about. You may wonder why we can't just square. Well, that's what I was talking about. You cannot distribute, and this shows you that you can't distribute. It doesn't work when you have real numbers in there as well. So what I'd like you to do right now is pause the video and try the problems in section 3.4c of the cooperative group problems. So multiply and simplify all these squares. X plus 5 squared, y squared plus 3 squared, and etc., etc. So go ahead, push pause on the video, and then come back. I'll give you about 5 seconds on the video. Come back and try those. All right, hopefully you went ahead and did that. What I'm going to do is I'm going to do each one of these 5 problems. So we're going to take x plus 5 times x plus 5, multiply that out in the first problem. When you do that, you get x squared. That's what you get when you take x times x. X times 5 is just 5x. 5 times x is another 5x. And then 5 times 5 is 25. By the way, sometimes people memorize like unique formulas for this. I don't. I like to just multiply polynomial times polynomial like we did in the first 2 parts of lesson 3-4. So here our final answer is going to be x squared plus 10x plus 25. All right. And there you go. Now let's look at the y squared plus 3 quantity squared. Again, we're going to start by rewriting this as y squared plus 3 times another y squared plus 3. And then when you multiply that out, distribute the y squared in, you get y to the 4th plus 3y squared. Excuse me. So y squared times 3 is 3y squared. 3 times y squared is another plus 3y squared. Notice that these middle terms are basically always going to be the same. And then plus 3 times a plus 3 is a plus 9. In other words, these two middle terms are always combining and they're always becoming the same, right? 5x, 5x, we can combine those. 3y squared, we can combine those. So my final answer on this problem number 2 is y to the 4th plus 6y squared plus 9. All right, let's take a look at problem number 3. That has a negative or a minus symbol in it. Same principles are going to always hold true. However, so when I look at z minus 10 squared, I should immediately think z minus 10 times another z minus 10. Z times z is z squared. Z times minus 10 is minus 10z. Minus 10 times z is another copy of minus 10z. And then lastly, negative 10 times another negative 10 is a plus 100. So my final answer there is z squared minus 20z plus 100. Again, these middle terms are always going to be identical if you've done it right and if you're squaring a binomial. All right, number 4, we have x plus y squared. So x plus y times another copy of x plus y. When you multiply this out, x times x is x squared. Now, x times y is just x times y. Then we go y times x. Well, that's just y times x. Y times y is plus y squared. And this is where we have to be really careful about understanding what like terms are. This is x to the first and y to the first. This is y to the first, x to the first. Those are actually like terms. And in fact, because this is x times y times x, you can reverse the order of multiplication. So y times x is the same thing as x times y when we're talking about real numbers. I have a parentheses there. So we do in fact get that middle terms to be, we do get those middle terms to be the same. And so the final answer is x squared plus 2xy plus y squared. Number 5, this last problem here. AB plus CD squared. So AB plus CD times itself times another copy of AB plus CD. Excuse me, trying to click there too fast. All right, so AB times AB is just A squared, B squared. All right, AB times CD is AB times CD, ABCD. Here I take CD times AB. Now, at this point, I'm just going to do my order. I know everything's multiplied, so I'm going to put the AB in front and the CD behind so I can see that it easily matches this other term. And then lastly, CD times another CD is C squared D squared. That gives a final answer of A squared B squared plus 2 A, B, C, D plus C squared D squared. So that's the final answer. Now that's the issue the book focuses on because again, a very common mistake is that people forget to write these things out and they end up just squaring the term in here and squaring the term in here. And that is obviously the incorrect thing because that does not give us our middle terms. All right, so be careful that you don't do that. Be careful that you can see this plus sign or the minus sign and then write it out as polynomial times polynomial. Now, one other thing that I like to point out that is not in the book is this issue. What if I want 3 polynomials multiplied times each other? All right, so basically what you're going to do on a problem like this is you're going to take these first 2 polynomials and you're going to multiply them together. And then you're going to get a result. Once you get that result, then that result is then going to be multiplied times the third polynomial. So that's what's going on. So here's what's going to happen. We're going to focus on the x plus 2 times the 2x plus 5. Whatever that result is going to be put into this first set of parentheses. And then whatever that result is going to be multiplied times the x minus 4. So let's do this. X times 2x is 2x squared. X times 5 is plus 5x. Then I distribute the 2 into just this polynomial here. 2 times 2x is a plus 4x. 2 times 5 is a plus 10. So that's what I get when I multiply these two polynomials. Let me highlight that. See if I can. Nope, can't do that. Dang it. I don't like that. So basically these two get multiplied and give me this. And then this x minus 4, nothing happens to. Now, I'm going to do one more step. Since the 5x and the 4x can combine, what I'm going to do is I'm going to rewrite that as 2x squared plus 9x plus 10, all multiplied times x minus 4. All right? And then I can multiply these two polynomials. And I multiply these two in the following way. 2x squared distributes into all the terms on the right. 9x distributes into all the terms on the right. 10 distributes into all the terms on the right. So 2x squared times x is 2x to the third. 2x squared times negative 4 is minus 8x squared. 9x times x is a plus 9x squared. 9x times negative 4 is minus 36x. 10 then gets multiplied, so 10 times x is plus 10x. And then 10 times negative 4 is a minus 40. Combining like terms gives you a 2x to the third plus 1x squared minus 26x minus 40. So when you want to multiply three polynomials all together, you take the first two, multiply those, get a result, and then once you got that result, then multiply it times the last one. By the way, it really didn't matter which two. You could have actually multiplied these last two first as well, and then took the x plus 2 times whatever that result is. And that is another property of multiplying three numbers. If you take three numbers, a times b times c, it doesn't matter which order you multiply them in, but you're going to multiply, for instance, you could say, well, the a times the b first, or you could do the b times the c first and then multiply by the a. The order of multiplication is not that important as long as you're multiplying everything. So there you go. That is, well, this would here would obviously be your final answer. So that is lesson 3-4.